Hello, boys and girls. I came across this interesting website that provides some weatherfront animations, and I thought I'd take some time to explain these to you because these fronts can get a little confusing. But I think we just need to have a general understanding of what's going on with a weather front. So, first of all, just as a review, the word front is a boundary or where two different the key word is different air masses meet. So at a front, different air masses meet each other. And air masses that are different don't get along. The different temperatures and pressures and humidities, when they make contact, it's kind of like a battle. And no matter what type of weather front it is, there's four different types. You can see those on the screen. You have your cold front, warm front, occluded, and stationary. No matter what type it is, it's going to form clouds and some kind of precipitation or possible storm is going to occur out of all of these. So that's kind of the battle between the air masses. So on this website, one of the basic types of fronts is a cold front. So this is a diagram of a cold front. And as you can see, we have blues and we have red arrows. And the cold air, so a cold air mass is coming towards a warm air mass. So you have cold and warm air colliding. Now, in this situation, the cold air is moving a lot faster. It's denser. So it goes and comes in and sinks underneath the warm air and forces that warm air up. So again, if I rewind this, the cold air is moving a lot faster. It's denser. Okay, cold air is denser than warm air. And as a result, it scoops underneath the warm air and forces it up. And you can notice as that warm air rises, it's going to first form clouds. And when the clouds get too full or saturated, they're going to release precipitation. So just one more time, that cold air, denser, scoops and lifts up the warm air, forming clouds and precipitation. Cold fronts generally result in more powerful storms. They're going to be the most powerful weather front. They're going to create storms, could be thunderstorms. As that warm air is forced up, it cools, makes clouds, and the precipitation falls as a result. Now, on a weather map, you would see a cold front. This is the symbol given to a cold front. It's actually blue triangles. Okay, so you would see this on a weather map, and the triangles point in the direction the cold front is moving. So this cold front is moving in this direction, the way those triangles point. And if you were experiencing a cold front will bring cold air or cooler air into your area. So it might have been warmer before the cold front came in, and then cooler air will come in and make the temperature drop. Okay, we experience this a lot in the summertime. It might be warm, and then all of a sudden this cold front comes in and it cools it down. It would be rain in the summer or spring, and in the fall it could bring snow or wintry weather. So that is your cold front. We also have something called a warm front. As I just get rid of these markings here. So a warm front is also going to involve warm and cold air. But now it's a little different. Before, they were coming at each other. Okay, for a cold front, they were moving towards each other. For a warm front, if you notice, the warm air and the cold air are moving in the same direction. So in this situation, the warm air is moving a lot faster than the cold air. And what happens is, again, cold air is denser. So the warm air moving faster goes right over top of the cold air and begins to rise up. It can't go into the cold air. It's just not as dense. So instead, it rises above it. And as it rises, again, clouds and precipitation will form. So one more time, the warm air mass is really moving faster, but since it's less dense, it can't go under the cold air. So instead, it rises above it and kind of takes it over on the top. And as a result, when it rises, you get these clouds and precipitation that fall as well. Again, you're going to have clouds, you're going to have storms, but it's not really storms, it's calmer weather, maybe light rain, light precipitation. It's not going to be as intense as a cold front. On a weather map, we would have these red circles represent a warm front. And same thing, the way the circle points is the direction the warm front is moving. So in this situation, it would be moving this way. And a warm front will bring warm air into the area. So it might have been colder before, but the warm front will bring warm air to where you're at. Okay, kind of the opposite of what a cold front would bring. Warm front brings warm air, cold front brings cold air. And again, both involving clouds and precipitation. So next we're going to move to a stationary front. Now the word stationary kind of means sitting still. So if we check out stationary, okay, in this situation we have warm and cold air coming at each other, but they kind of reach a standstill. Okay, one's not going under the other, one's not going above, they kind of meet and there's a standstill. And we do have weather that results as the result of the standstill. We have clouds and rain and precipitation, and it can kind of last a while because nothing's really happening. They just meet, there's a standstill, and you get some, weather for a while that will eventually go away, but you don't have that under over like we did for the warm and cold front. So on a weather map, check out these symbols. This would represent a stationary front, and you kind of have a mix of circles and triangles that alternate. And you can kind of see in the animation that they come together, but it's kind of just a stalemate. They're stalled. And some air does get forced up, and you get your clouds and your precipitation as a result. So the last one, an occluded front, is probably the most difficult to kind of wrap your head around. So an occluded front, you get there. In this situation, you have two cold air masses. Okay, you can kind of notice one here on the left, and we have another one over here on the right. Two separate cold air masses. They're kind of moving along, and eventually they scoop up a warm air mass that's in the middle of them. So there's two separate cold air masses. There's a warm air mass that was in the middle, and eventually as they're all moving, the cold air masses scoop up the warm air and force it up to, again, let me get this going here. As they move along, the one on the left eventually is moving faster. It starts to catch up with the one on the right, and it forces that warm air in the middle up. Okay, so it kind of scoops it up. The two sides scoop up the middle, and again, you get your clouds, you get your precipitation, you get your rain, your storms, as it pushes that warm air up. All right, so as you can see, there's 4 different ways that this can happen. In any situation, you have 2 different air masses either interacting or coming at each other, or something happening between 2 different things. The big picture here is not memorizing the different 4 types, but for you to see that when they interact, they all have the same thing in common. They cause cloud formation, which can then cause precipitation and storms. This is why we have this type of weather. Okay, these fronts create that for us. So hopefully this helped a little bit. I'm going to post this animation on Google Classroom as well. You're welcome to play along with it. But again, the big picture is they produce clouds, they produce weak to strong storms because of these different air masses that don't really get along meeting each other. Okay? Oh, and one more thing, almost forgot. On a weather map, an occluded front also has its own symbol, which you can see here as well. Okay, circle, triangle, alternation.